Yesterday we introduced the idea of projectile motion. We said a projectile is anything that flies through the air under the influence of only gravity. Do you guys remember the shape of the path of a projectile as it flies through the air under the influence of just gravity? And we drew a little picture yesterday. We said, first of all, that this object doesn't go out, look down, and then fall straight down. That would be a square or a rectangle, so it's not a square or a rectangle. It doesn't go straight down like this, so it's not a triangle. The shape of the path followed by this object would be something that looks like this. What's that shape called? Yep. Yeah, it's called a parabola, right. Now, because there is only one force acting on this projectile as it moves through the air, and that force is gravity, a downward force, the x component of the motion, the horizontal motion, doesn't change. The horizontal velocity stays the same. So if we take a look at the velocity here horizontally, it's going to be the same horizontally as it goes through this entire path. It's not changing. Vertically, however, we started off at 0. Okay, as time went on, the vertical velocity increased and increased and increased because gravity was pulling down on it a little bit more each time. Does that make sense? Now, we want to describe the x component. If it's constant velocity, we're going to describe the x component by using our group A equation. V is equal to delta D over delta T. The vertical component can be described by any of the acceleration equations, particularly one acceleration equation. It's the one that almost always works for us, so it's the one that we always try first. D is equal to VIT plus 1/2 AET squared. Liam, question? Yep. Yeah, that's right. Assuming there's no air resistance. I had a physics professor in my second year at university, and his definition of physics, I always liked this definition. I always kind of go back to it. He defined physics not as energy and matter and the interaction between the two like I did at the beginning of this course. He defined physics as the art of making the right approximation. So basically what he was saying is this. Okay, nothing we do in physics is precise. Everything is a bit of an approximation. We want to be precise. We want to be perfect at everything that we do. But there's so many, almost an infinite number of factors that act on everything that we can't be that precise. What we have to do is make a good approximation. In most cases, in these projectile motion questions, it's a good approximation to assume no air resistance. Now, every once in a while, okay, we're off quite a bit by assuming no air resistance, but most times we're not. Okay, so we will, unless you're told otherwise, assume that there's no air resistance. Okay, so no forces horizontally, constant velocity. There is a force vertically acting downwards, gravity, so our y component can be described by one of the group B equations, usually the one that you see up on the board. Now, I want to take a closer look at this one. Okay, we never talked about this aspect of it yesterday. D is equal to VIT plus 1/2 AT squared. We said yesterday, and we reviewed this today, we said the shape of the path of this object is a parabola. Well, where does that come from? Do you guys remember the equation for a parabola from math class? Who knows what a parabola is? Who's done parabolas in math class? Okay, about half of you. A little bit more than half of you. Does anybody remember the equation that describes a parabola from math class? Jazzy? About ax squared plus bx plus c. Do you recognize that? Okay. There are various forms of equations, including the equation for a straight line graph, let alone a parabola. But the simplest form of the equation, y is equal to ax squared plus bx plus c. Do you recognize that one? Okay, you guys have seen that? Those of you who have done this in math class, that is. Let's take a look at this equation right here. D is equal to VIT plus 1/2 AT squared. And let's, for just a second, say delta D is dF minus di, right? Final position minus initial position. Is that the same thing? Displacement, final position minus initial position. Is that okay to do? I haven't committed any fouls by changing that equation around a little bit. All right, let's rearrange it a little bit then. Let's say dF is equal to 1 half AT squared plus VIT. Now let's take the DI over by adding. Is that okay? Is that the same thing? DF is equal to 1 half AT squared plus VIT plus DI. Well, this equation would describe this graph. Okay, this graph, or which is a parabola, or this graph, which is a parabola. So y and x. This equation would describe this graph, d versus t, in a shape that looks like this. Now take a look at the two equations again. My y-axis is y. My y-axis is my final position. My x-axis right here is t. Okay, my x-axis is t. The value of a right here, well, it's an upside down parabola, so it's going to be a negative a there, right? Well, what do I have here? Negative, or 1 half of a, 1 half of negative 9.81. DI, okay, that's my initial. C, that's my initial. Okay, this is the equation for a parabola. It's just when we take away all of that stuff that I just did, it just looks a little bit different than the base equation for a parabola that you learned in math class, but it's exactly the same thing. Does that make sense? It is a parabola, and it is mathematically a parabola too. It's not just me, oh, that looks like a parabola. Let's call it a parabola because that looks like it's the shape of a parabola, okay? It is a parabola mathematically. All right, what's the general strategy of solving these problems? Plug numbers in, see what comes out. Plug numbers in, see what comes out. Don't panic about trying to find something. If you're looking for D, don't worry about it. Just plug whatever you have in, see what comes out of it. Okay, and then use that to find something else if you need to. We had 3 questions for homework last night. As I took a look at them just a second ago, there were some people that said, you know what, I had a little bit of trouble with question number 3, or I had question with 2, or whatever. And in some cases, that's absolutely fine. But listen, if you're having trouble with questions 2 or 3 or whatever, but you're not following the example that I gave you yesterday in class, okay, then that's not good enough. Okay, we know the structure of each of these. Okay, they all look like this. We start off every single one of them, v is equal to delta d over delta t, and d is equal to VIT plus 1 half AT squared. If you didn't start off that way, then you weren't listening close enough yesterday, or you didn't go back to your notes well enough yesterday, because that's the way we start off all of them. If you have trouble beyond that, okay, I can accept that. Okay, because they're all a little bit different once we get past that. But we know where to start on all of them. In fact, I'll tell you right now, there's somewhere around 25 multiple choice questions on your final exam. And then there's somewhere around 9, I can't remember the exact number, 9 kind of written questions like this on your final exam. The first written question is a projectile motion question. The first one, question number 1, is a projectile motion question. And guess how you'll start it? This way. If you don't start it this way, okay, then I don't know what to say. Okay, I'm telling you what the question is. I'm telling you got to start it this way. Okay, you're guaranteed of getting points here. If you don't do that, I guess that's too bad. Okay, we got to be able to do this. We got to be able to follow the rules that always apply. Okay, always those 2 equations. All right, which questions do we need to go over here, okay? Which questions you struggled with a little bit do we need to go over? Joe? 3? Okay. Any others? How about number 2, actually? Number 2 is a bit trickier. It's not tricky to start off. We start them all off exactly the same. It's a little bit trickier to actually do it, though, because of a number that's in there that we don't need. Let's go number 2 first. It says an arrow is fired horizontally with a speed of 20 meters per second, 25 meters per second off of a cliff. Here's the cliff. Here's, I've got it drawn as a ball as opposed to an arrow, but it doesn't really matter. It goes down like this. Okay, my time is 2.50 seconds. We want to know how far it falls, the distance the arrow will drop in 2.5 seconds. Break it up into x and y. X is v is equal to d over t. It always is. No exceptions every single time. The y component, VIT plus 1 half AT squared. Now, 1% of the time, and maybe that doesn't work for us, the second equation. But since it works 99% of the time for us, let's try it first. If it doesn't work, well, let's try something else. Let's plug some numbers in. We know the speed horizontally is 25 meters per second. Do we know how far it goes horizontally? No, we don't. Do we know how long it's in the air for? Yeah, we do. It's 2.50 seconds. Let's multiply those together. We get 62.5 meters. Is that my answer? No, what have we just found? The horizontal displacement. How far the arrow goes in 2.5 seconds. Is that what we're looking for? No. Maybe that's helpful to me later on. Maybe it's not. Okay, no big deal. It's not wrong. It's just not what I'm asked to solve for. All right, y. Do we know what the delta D is for the y component? Do we know how far it falls? 150 meters, isn't it? Okay. Yeah. That's a red herring, okay? I call it blue car phenomenon. Okay, here's a question that I'll throw at you, okay? A blue car travels down the road at 20 meters per second for 3 minutes. How far has it traveled? What are some of the givens that we have here? Speed is 20 meters per second. Time is 3 minutes. We're looking for delta D, the displacement. What else are we given? The color of the car was blue, right? Do we really need the color of the car? No, it doesn't matter, right? Does it matter how high the cliff is here? No. It doesn't say it falls to the bottom. Okay, that's like the color of the car. Okay, it doesn't say it falls to the bottom, so the height of the cliff is irrelevant there. We don't know what delta D is. In fact, that's what we're trying to find. VI is 0 for the y component because it's launched this way, right? In other words, how fast is it moving downward when it starts? It isn't. It's moving downward shortly after it starts. A is neg 9.81 because we're on Earth, and T is 2.50 seconds. So let's solve for delta D here. Let's pull the calculator out here. 0.5 times negative 9.81 times 2.5 squared gives me negative 30.7. Who got that? So it didn't fall 150 meters at all. It fell 30.7 meters. Why did I get negative in there? Because it, yeah, and the negative means it fell, Luis? Yes. So it's down, right. It's a downward displacement. It fell downward. I'd mark that right, although technically you're asked not for the displacement, you're asked for the distance. So what's the technically correct answer there? 30.7, right? We dropped the negative because we're looking for distance. Okay, I wouldn't mark that wrong, though. Is that okay? Who got that again? Good. Okay, let's take a look at number 3 here. What's the horizontal speed of an object if it lands 40 meters away from the base of a 100-meter tall cliff? Here's the cliff. Okay, we're looking for the horizontal speed of the ball. The cliff is 100 meters high. Follows a parabola here and lands 40 meters away from the base of that cliff. You got to figure that's going to be pretty fast, right? It's got to be moving pretty fast if it lands 40 meters away from the cliff. Here's our x's, here's our y's. What do we start off with for x? Okay, we've got to know this now, right? What are we starting off with for x? What equation are we going to always start off with for x? Good. V is equal to delta D over delta T. Excellent. We have to because its x velocity isn't changing. Good. Jeff, what equation do you want to start off with for y? Yeah, VIT plus 1/2 AT squared. Didn't quite say it right, but I knew what you meant there, right? On your data sheet, you'd copy it down correctly there. D is equal to VIT plus 1/2 AT squared. Now, that's not a certainty. Okay, the first one is. The second one is, look, it works 99% of the time. Let's give it a try. Worst case scenario is we got to try something else, right? Let's plug some numbers in. We don't know what V is. Do we know what delta D is here? Remember, we're doing X, right? We're doing X. Do we know what delta D is? Oliver, what's the value of delta D there? Yes, good. Why'd you pick 40 instead of 100? Good. So this would be the 100, right? This would be the 40. Good. Do we know what T is? We don't. Okay, so that's two unknowns. It wasn't very helpful what I just did, but that's okay. What's delta D here again? Not 100, but you're close. So what's delta D here? Negative 100 because it falls downward, right? The I is 0 because it starts launched this way horizontally. 0 times T is 0. A is negative 9.81 times T squared. Half of negative 9.81 is negative 4.905. Let's pull this up on our calculators here. Make sure we can do it. Let's say negative 100 divided by negative 4.905. Now let's square root that. We end up with 4.5152. Notice I'm using the unrounded number because it's not my final answer. Let's take that over here and say 40 divided by 4.5152. We get 8.86 meters per second. Again, if you struggled with that question a little bit, that's okay if you didn't get the question. Okay, it's not okay if you didn't write down this and this, because that's a recipe, right? We don't have to think to do that. We just write down what we always write down for these types of problems for that, okay? We've got to get that far. Everybody's got to get that far. Beyond that, that's when we got to think a little bit, okay? Step outside the recipe. That makes some sense? Good. Okay, I'm going to give you a worksheet, and I'm going to ask, there's two sides to this worksheet. I'm going to ask you to take a look at the front side only of the worksheet. Don't flip it over. Don't try the back side, okay? It's also projectile motion, but it's questions that you haven't learned to do yet. So don't try the back side, just because I don't want you to start teaching yourself the wrong way before I teach you the right way, okay? I'll give you a little bit of time here in class, not time to do the entire thing, but time at least to get a start and ask me a couple questions if you're struggling a little bit, okay?